In this video, I'm going to talk about the reflection of sound. First, we'll see what is called the reflection. When I throw the ball to the wall, it comes back. This is the reflection. To understand about the reflection, I'll show you how the light gets reflected first. When the light is falling onto a surface, this is the surface, light falls as rays. This ray is called the incident ray. And I can draw a normal. Normal means a perpendicular line to the point where the incident ray meets the surface. Normal. Then the reflection. The ray gets reflected. This is the reflected ray. And the angle in between the incident ray and the normal is called the angle of incident I. An angle in between the normal and the reflected ray is called the angle of reflection, called the R. In reflection, this I is always equal to the R. That means the angle of incident is equal to the angle of reflection. The other requirement in the reflection is, if I take this pencil as the incident ray, and I can use this yellow color pencil as the normal. Normal is always 90 degrees to the surface. Therefore, it is perpendicular. So, incident ray, normal and the reflected ray by this pencil. So, all the three things are in the same plane. In reflection, incident ray, normal, reflected ray are in the same plane. If they were as this, we can't say as they are in the same plane. But they are in the same plane as I am showing here. As I have mentioned, the reflection of the sound is also taking place according to according to what I have explained below. The sound also get reflected by making incident ray and the reflected ray, and the angle of incident and angle of refraction are equal. So sound also get reflected as this. Because of the reflection of sound, these two outcomes are generated. First one is the echo or reverberation. We'll talk about the echo and reverberation in details. Echo is the hearing back of the reflected ray. Hearing back of the reflected sound wave is called the echo. But you will think that if the reflected rays are heard back, so why can't we hear what we talk now? Always we don't experience this echo. The reason is our brain takes an interval to identify one sound wave from the other. Our brain needs an interval of 1 point, that means an interval of 0.1 second, 1/10 of a second time period. So luckily, therefore, we don't hear every sound because brain needs some kind of, that means interval. Therefore, luckily we don't hear all the sound back. If it is so it would be a very disturbing environment if we can hear every sound back. Now we'll see. So what type of a distance should be there to hear that sound back? If there's a sound source here, a man, he's producing a sound. Longitudinal waves are traveling through the air by compressions and rarefactions. So there should be an obstacle to get the sound reflected back. Right, so the reflected sound wave is coming back. to the listener. So sound ray should go from the source to the obstacle, that means this distance, and it should come back to the listener's ear, passing the same distance again. To pass this total distance, it should take 0.1 second. Right, now we'll see usually the speed of the sound in the air is 340 meters per second. What does it mean? It takes 300, that means it takes 1 second to pass 340 meters in the normal room temperature. Sound takes 1 second to pass 340 meters in the air. Right, now speed. So we know that the speed is equal to the distance over time. So speed is 340 meters per second. The distance, have a clear look at this. So distance means the sound should go this way and it should come back. So altogether the total distance means 2d. Time is 0.1 second. If we want to find the d, we have to subject the d. If we subject it, 2d is equal to 340 meters per second into 0.1 second. Negative, -1 and +1 here for the second is cancelling. Therefore, the answer is 2d is equal to 340 meters into 0.1. So the final answer comes as 34 meters equals to the 2d. If we want to find the d means 34 divided by 2 meters. That means 17 meters. Therefore, the distance should be in between the source and the obstacle at least 17 meters or more than that. Otherwise, the time will be shorter, smaller than 0.1 second. Therefore, our brain won't understand that. If we want to hear the echo, at least there should be 17 meters distance. This echo is very important. Therefore, we humans are using the echo and also animals use echo. Especially bats use echolocation for their locating. Because their vision is very poor, what they do is they release ultrasound waves which are very high in frequency, higher than 20,000 hertz, and then they have a sensor to get the reflecting rays and they determine the distance in between the obstacle and them. That's how they get located. Next one, we humans also use ultrasound rays and the echo of ultrasound rays in ultrasound scanners where the doctors use it to identify internal organs, and also some scanners are used to determine the geography of the sea under the water and also determine things under the soil, oil wells and some valuable gems inside soil. So for such purposes we use echo. I think you have learned a lot today. Therefore we'll meet again in another part of this lesson. Thank you very much.